Hello, Ramgineers in my ENGR 4201 Professional Practices class, and welcome to the last lesson of the semester. This should be exciting. This lesson is on professional engineering registration, particularly the Texas laws and rules. These are our learning objectives for the class. They're all posted on Blackboard, so I'm not going to go through them in terrible detail, but they generally the short version of these is by the end of this, you should be able to explain why Texas has a professional registration program, how that program is generally outlined, and most importantly, you should be able to discuss how the relationship between the public and the professional engineer is structured and the tension in that relationship and how the professional engineers work both in the public interest and in their own interest. In this presentation, I'm going to briefly go over some history of professional engineering registration, talk about the legal authority for registration, present the purposes of professional registration laws and rules. I'll talk about the roles of a bunch of national organizations that play a role within professional registration. And finally, I'll present the team exercise that you're all going to do, which is an analysis of this public-professional relationship, this relationship between engineers and the public. So my first question, which I'd be asking if we were all in class to get you to brainstorm about, is why do engineers get registered? Only 20% of practicing engineers, maybe even less than 20%, are registered. So why do people do it? For those that do get registered, why does that happen? Well, in my experience, when I just talk to people about that are registered and why they get registered, it boils down to maybe three main reasons. The first is honor and recognition. We all would like to be known as being somebody special, and to be a registered professional engineer is a badge of honor and a special honor. It puts you in a certain level of expertise and gets you recognized. And so just that warm tummy feeling of knowing that you're a professional engineer is enough to get some people registered. Obviously not too many, or we would have more than 20% doing that. The second one, which is a real biggie, is financial interests. There's times when being registered is going to be in your financial interests. And a great example of this is engineers who do expert witness testimony in the courtrooms. It's almost essential that they become registered professional engineers because they can't stand the cross-examination they're going to get when the other attorney asks them if they're a professional engineer, and if they say no, they're going to say, well, why aren't you a registered professional engineer, and what makes you think you're qualified to give expert witness testimony if you're not even registered as a professional engineer? So lots of times there's financial interest to that. The third one is that in many places the law requires it. And so if the law requires professional engineering registration to do something, you need to have professional engineers to do that. That ties back to the second reason, because companies that need professional engineers generally pay more to have registered engineers work for them than non-registered because of that special need, the special skill that they have to provide the legal requirements for the work that they do. And the reason that so few engineers are registered is most engineers aren't required by law to be registered. Now in civil engineering, that's very different. Many civil engineering functions must be performed by registered civil engineers. And so the registration rate in civil engineers is actually over 50%. But the total registration of all engineers is less than 20%. So to discuss professional registration and where it came from, we really need to go back to the huge changes that occurred in society during the technological revolution, or the second industrial revolution. This occurred roughly around the time of the Civil War through just before the First World War. During this time, there's a huge increase in industrial output throughout the world. And in the United States, that was an 8-fold increase in industrial output. We went from a very agrarian society to a society highly dependent on industrial output. This coincided with the rapid expansion of engineering training. If you wanted to be an engineer before 1840, there were only two places you could get engineering education, and that was at West Point or Rensselaer Polytechnic Institute. And Rensselaer Polytechnic Institute didn't open until, I believe, 1928. In the next decade and a half or so, 4 more schools that are well-known and historic schools in engineering, Yale, Harvard, University of Michigan, and MIT added programs in engineering. And in 1862, a really important legislation was passed by the U.S. Congress right in near the end of the Civil War, which was a Morrill Act, which funded public agriculture and mechanical colleges throughout the United States. That's where all the land grant colleges came from. That's where Texas A&M and uh, University of Illinois and many of the land grant colleges came from. So that provided a huge amount of capital influx into technical education, and then by the end of the century, there's over 110 colleges offering some kinds of engineering programs. And the quality and coverage in these was highly varied. This technological revolution brought about massive improvements in public health and sanitation and transportation and many other public benefits, but it also brought with it many negative impacts, in many cases due to poor engineering skills. Boiler explosions, for example, were just rampant during at the turn of the century, killing hundreds and hundreds of people. And another great example was railroad bridge failures. There were just many failures of railroad bridges throughout the country as our transportation system grew so quickly. And in many cases, these were just poor understandings of the engineering fundamentals that were the root source of many of these problems. This led to the creation of many professional societies, both the big boom in engineers, the number of engineers, and in the need to provide better control of the engineering professions. So most of all the big ones were all started in the late 19th centuries. American Society of Civil Engineers was the first in 1869. Followed very quickly by the American Institute of Mining Engineers in 1871. The mechanical engineers joined soon after that, in about a decade after that in 1880. And the American Institute of Electrical Engineers was started in 1884. All of these institutions are still in existence in one way or another. AIEE has turned into IEEE, the Institute of Electrical and the Institute of Electronics and Electrical Engineers. These professional societies provided both technical advancement for the engineering professions and also social recognition. They established guidelines for engineering education. Many of these were, though, very closely tied to industry and very driven by industry needs, more so than the needs of society or even the needs of the profession. American Society of Civil Engineers was one of the few that tried to separate itself from industry and not be tied directly to into industry. But all the other major professional societies were very closely tied to industry and actually in many cases sponsored by industry. And in many cases, industry leaders and chairmen of large industrial corporations actually sat on the boards of these companies, of these professional societies. Initially, these societies opposed state regulation of engineering. They thought that the best way to regulate professional engineering was within the professions themselves. And for many decades, they opposed state regulation of engineering. Ultimately, they failed to properly regulate the engineering from within, and other forces led to public legislation about engineering. Those forces that leading to public regulation of engineering led from a desire to professionalize the engineering profession. This was driven by engineers in many cases. In the early part of the 20th century, the younger engineers had all come through college programs and were college educated, where the older engineers had all been self-educated, and many of the younger engineers actually looked down upon the older engineers as not being as skilled or understanding. Also, as the Depression came on and wages got depressed, there was a desire among some engineers to control the number of engineers to raise salaries. So that monetary desire that we discussed earlier was definitely part of what drove legislation for engineering. And finally, next, the other key point was to protect the safety of the public. The public was demanding better and safer engineering due to the havoc that was wreaked by the technological revolution. And finally, the failure of professional organizations to improve this quality, to provide that public demand, is what led to the state regulation of engineering. So a quick blaze through the history of adoption of state regulations. The very first state regulation of engineering was in Wyoming in 1907, and they established their regulation was fairly limited. It was really related to surveyors and civil engineering, and it was really driven by water rights issues. We're here in West Texas. We understand how incredibly important water rights are in the West, and that was also true in Wyoming. And in the turn of the century, the poor quality of the hydrology studies were leading to just huge misallocations of the state's water resources, which was a key public state resource. And that desire to get better quality documents to properly allocate water resources is what drove the legislation in Wyoming. In 1910, a really key Supreme Court decision came out that really established the state authority to regulate professionals. The case was Watson versus Maryland, and part of that court ruling stated that trades and callings, particularly those which closely concern the public health, states had the rights to regulate. So this actually cemented the state authority to regulate professional registration. This particular decision was about medical doctors, but it was immediately applied to both lawyers and engineering. And so this is the key regulation or Supreme Court decision that gives states the authorities to regulate professions. And in 1920, there were 10 states with regulations about professional engineering. 7 of them got together to create the National Council of Examiners of Engineering and Surveying to try and bring some consistency to the regulations between states. And that is the precursor to our NCEES, which we still have today. And then by 1947, all states had some sort of engineering legislation law, and Montana was the last to enact those. So that's a relatively short period there to go from basically no regulation of engineering to complete regulation. Many of these state regulations were driven by significant failures of engineering and engineering disasters that caused lives. In California, the failure of the St. Francis Dam in Los Angeles was a key driver for legislation. These are pictures of the dam after the failure. This dam catastrophically failed on March 12th in 1928. We don't really know how many people were killed in it. The estimate was at least 431 people were killed in this dam failure. The designer is William Mulholland, which if you lived in Los Angeles, you may have been on Mulholland Drive. He's a well-known engineer in the Los Angeles area. He was self-taught. The causes of this failure were driven by not understanding the geology area and realizing that he was building this dam right on a structural fault. And then also they made a number of design changes during the construction of the dam, which ultimately led to its failure. As a result of that, there were a number of legislation changes in California, but one of them was just a year later. California instituted the Board of Registration for Civil Engineers with the explicit desire to protect the public. Here in Texas, our legislation was driven by an equally catastrophic engineering failure, the New London school explosion on March 18th, 1937. This explosion killed 295 students and teachers in just a few seconds. It was, at the time, the 3rd deadliest disaster within Texas. The design of the building included installing 72 separate gas heaters installed throughout the entire building instead of what would have been typically a central boiler system. These gas heaters were directly connected to an oil company's waste gas supply line because it saved money. And at those days, the natural gas was odorless. Well, natural gas is naturally odorless. In those days, it didn't have the mercaptans added to it that gives it that stinky flavor that we know of today. And so the leaks in the system went undetected. It leaked, and the design of the building was such that there was a large cavity under the building where the gas pooled. And then when it had a chance to ignite, there was this huge explosion, and it destroyed the entire school and killed all but 100. There were over 400 people in the building at the time, and I think all but 150 of them or something like that were killed. The ability of the state legislature to enact laws quickly was amazing. Within weeks, they added a law to require mercaptans to be added to gas. That's what creates the strong odor of gas as we know it today. And then that same year, they enacted the Engineering Registration Act, which was the first regulation of engineering within Texas. So it's not accidental that many of these state legislations were driven by technical failures of engineers to protect the public. So that leads us to a quick summary of what the purpose of engineering regulation is. The first and foremost reason for engineering regulation in every piece of engineering regulation I've ever read is to protect the life, health, and safety of the public. There's also a desire to ensure a minimum level of engineering competency. And another aspect of this is these limits the practice of engineering to qualified professionals, which actually is a bonus to the engineers. By limiting the practice of engineering, it limits the number of people practicing, it controls the supply of engineers, which raises the cost of engineering and raises our salaries. So there's a two-way street going on here within this engineering regulation. And it's clear that many of the regulations, engineers were involved in writing with these regulations with the express intent in many cases to try and raise the profile of engineering and the value of it. There are a number of national organizations involved in engineering registration. The biggest organizations are the state legislatures. They're the ones that have the legal authority to control registration and to make the laws. So we have, I think, 52 different laws for registration within the United States. We have 50 for the states, and then the District of Columbia and Guam all have legislation about professional registration, and they're not the same. The National Society of Professional Engineers has a mission to foster licensed professionals in the service to society, and they provide a lot of guidance for professionals and professional registration. The National Society of Engineering Examiners and Surveying, their mission is to advance the licensure of engineers and surveyors in order to safeguard the health, safety, and welfare of the public. They provide a lot of common guidance, and they're the ones that establish the common exams. The NCES is an important national organization. ABET is our engineering accreditation organization. Their mission is to assure confidence in university programs in STEM disciplines. They accredit programs, not just engineering programs, but they are the main guarantor of the quality of university engineering programs. And finally, there's the professional societies. There's professional societies for every engineering discipline, just about civil engineering, mechanical engineering, industrial engineering, manufacturing engineering, chemical engineering. And essentially all of them, someplace in their mission statement, have as their mission is to advance their particular engineering discipline and protect the public health, safety, and welfare. So you see this tension or this dynamic between advancing engineering professions and protecting the public in all the missions of all these organizations. So let's talk a little bit about the registration process. Although it's different in every state is controlled separately. They all follow have the same 4 requirements. And those requirements are to achieve some level of education. Typically all state requirements, if you're not required to graduate from an ABET accredited program, that's generally an assumption. Most of them have some other way for you to get qualified or demonstrate your education if it's not from an ABET accredited school, but most of them, that's the basic assumption, is that you're going to be graduating from an ABET accredited program. They all require you to pass exams. There are 2 key exams we'll talk about in a minute, but they're not the only ones. I think you know the 2 key already, which is the Fundamentals of Engineering exam, which you all should be ready to pass now, and then the Professional Engineering exam. But there are others. In Texas, you have to pass a Texas ethics exam, which I'm going to make you do as part of this lesson. And in California, if you're a civil engineer, you have to pass a surveying exam and a seismic exam. So there's the exams are not the same in every state, although all state exams require 2 key ones that are the same. You have to obtain some level of practice, and then you have to pay money. The key exams that are standardized are the Fundamentals of Engineering exam and the Professional Practices exam, and those are controlled and regulated and standardized by NCES. So those are consistent across all states, but most states require additional exams in addition to those. In terms of experience, the required experience is typically someplace between 4 and 6 years. How that is exactly specified is different. For example, in California, it has a requirement for 6 years, but if you graduated from an ABET accredited program, you get 2 years of credit for that. And if you did a master's degree or an advanced degree, you can get 1 year of credit for that. So in California, in practice, you can actually get registered 3 years after you graduated from the university. Where in Texas, the requirement is for 4 years, and you don't get any credit for your undergraduate education, so it takes at least 4 years in Texas. So you have to read the details to understand this, but generally the requirements are between 4 and 6 years. The costs are generally in the hundreds of dollars, and then the annual renewals, I think right now Texas renewals are every other year, and I think they're $300, I want to say that's right. I can't remember now. I'm paying registration in 3 different states, and I can't remember which one's which anymore. But the cost to sit the exams is hundreds of dollars. And then NCES tries to standardize the legislation among the states. They have what they call model legislation. So they are active in trying to make these state regulations more uniform. But as you can imagine, the Texas legislature doesn't really care what NCES has to say. They care what Texans have to say. And so in spite of the efforts of NCES to standardize registration laws, they are notably different in every state, and you need to be aware of the registration laws in any state where you're going to practice. So that's a quick overview of everything. I now want to talk about the group exercises, what you're going to do to wrap up this whole last block of the course. The first thing you're going to do is take and pass the PE ethics exam. So I'm posting that exam within Blackboard, and you guys this is going to force you to go through the Texas regulation and look up some of the things that are important in there. You get to do this as a group, so it shouldn't be too difficult or take too long. And the second thing I'm going to have you do, which is an exercise that we would normally do in class, and again, you're going to do this in teams, is to analyze the Texas PE laws and rules and see how they compare to Greenwood's attributes of a profession, which we covered way back in lesson number 1 of this class. So this is a nice bookend to the whole class. And just to remind you, Greenwood said that all professions need to have a systematic body of knowledge, that within that profession that there's a certain value put to the professional authority, where the professional, you have to be within the profession to have the authority and to know what to do, that it's not a matter of taste or desire or interest, that the clients don't necessarily have the authority to make the decisions they need. The third one, which is really important, is the sanction of the community. This is that key trade-off between protection of the community and the community giving the profession a monopoly to operate. And then regulative code of ethics and professional culture. So your assignment, which will be detailed in Blackboard, is to read the professional laws within Texas. You take the PE ethics exam. That's going to force you to make sure you read through them. And then answer some short questions about the laws, and then prepare a short write-up analyzing how Greenwood's attributes and the Texas laws either work together or don't work together, how they're the same or different. I think you'll find this really instructive and interesting. And in our very last lesson, I'll do some reviews of what you learned from this, and we'll talk about the final exam. So I hope you enjoy this lesson. I'll give you the better part of an entire week to work on this with your teams. And I'll see you online the last day of class. Have a great Ramgineer day.